Hello people, welcome one and all to Jojo's Learning Club.
Hello guys, welcome back to my channel Jojo's Learning Club. So today I'll be discussing on exponential functions, and today also about what are exponential functions and how to evaluate it. So what are actually exponential functions? Exponential functions are functions written in the form e raised to x, where e being a constant, a mathematical constant, and x being a real number. So x is here a real number and e is a exponent term, and this is a mathematical constant. When the value of x is 1, e raised to 1, that is e, is approximated to have a value of 2.7183. These exponent actually arises from the natural laws of growth and decay, and it is also used as a base for natural logarithms. What do I mean by that? For logarithmic 10, then it is common logarithms. When it is a base of e, then it is for natural logarithms. So, or it is also approximated as ln. So this is a natural logarithm, and in that the base is taken as this exponent term e. Okay, and now let's find how to evaluate it. There are three methods to evaluate exponents. Yeah, the first method is using scientific notation calculators. That is most commonly used practice to find the value of exponential functions, or you can also find the values using a power series. You have a formula, you have to substitute the values from the e raised to x function, and then you can find the value of exponential functions. Or also there's a table with listed with up to 4 significant numbers or up to 4 decimal places. The values will be listed in a table. From that you have to choose the correct value and you can take the values. So these are the three common methods, and out of these, the tables of exponential functions are rarely used nowadays, because after the generation of scientific notation calculators, these tables are rarely used because with a one click you can easily get your values. In scientific notation calculators, you can see that this is an example of one of the scientific notation calculators. There is a term ln here, that is natural logarithm. If you see, and the top of it you can see that there's a e component or a e term. So if you simply press on ln, you just get the how to find the if you simply press ln, you can see that ln appears here. So with this you can only find the natural logarithm. But if you wanted to get e term or the exponent term in it, first you have to press on the shift button, then you have to select the ln button, then you can get the top portion, that is e component in it. So here it is asked e raised to. If you want to fill with different values, let's find what is the value of e raised to 1 using scientific calculator. So what is the value? It is 2.718281828, and it goes on. So using scientific notation calculators, you can get up to 8 to 9 significant figures. Yeah, and it is said, now let's solve all these problems also. So up to 4 significant figures it is said that. So I'm going to find this up to 4 significant figures. To 2.718. Yeah, up to 4 significant figures I have found. Now let's find what is the value of e raised to 2.4. For that, similarly, again what you have to do, press shift, then select ln, then enter your value for x. That is it should be a real number, that's it. 2.4. What is the value? 11.02317638. But in the question it is asked up to 5 decimal places. So from here 1, 2, 3, 4, 5. So your answer is 11.02317 is your final answer. And now let's find for what is for e raised to minus 1.618 up to 4 significant figures. So first again press shift and then select ln minus 1.618. The value is 0.1982948.925. It is set up to 4 significant figures. So I take it 0.1982. So this is the value for these exponential function. So this is how you find the values using our scientific notation calculator. And now let's learn how to find the value of exponential functions using a power series. So these power series, using power series, you can find the value of exponential functions up to any number of accuracy, or like any number of decimal points. The more the number of terms you take, it will be more closer to the actual value. And this series, the value is said to be converging if all the terms of x are taken and added together, then it is called a converging value. So in this is the formula to find the power series. Let's read it. So e raised to x is given as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial, and it goes on. So the next term would be x raised to 5 factorial by plus x raised to 6 factorial, x raised to 6 by 6 factorial, then x raised to 7 by 7 factorial, and so on. So to get a converging value, you have to add all these values up to the infinite terms, then you will get the actual value of exponential function, and this is the actual value. More the number of terms you take to find the value of e raised to x, then your value would be more closer to the actual value. So if you take up to 5 terms, and the another one problem you take up to 7 terms, the value with the 7 terms would be more accurate than the terms with 5 terms. Okay, so that's the difference. So this is the power series. You can see that 1 factorial, 2 factorial, 3 factorial. What are these factorial notations? When you take, for example, n factorial, it is a product of first n natural numbers. Then what it would be for 4 factorial? It would be the product of first 4 natural numbers. And if it is 2 factorial, what it would be? Product of first 2 natural numbers. Which are they? 1 and 2. So 2 factorial is 1 into 2. And 4 factorial is what? Product of 4 natural numbers. Which are these numbers? 1, 2 into 2 into 3 into 4. And what it would be for 5 factorial? 1 into 2 into 3 into 4 into 5. So let's write it. 1 into 2 into 3 into 4 into 5. If you have any doubts on these sections, please refer my sections on permutation and combination, where I have discussed a lecture on complete on factorial notations, and I also done some problems based on factorial notations. Okay, so that's all about factorials, and let's do some two problems using exponential functions. Using power series. So the first problem is e raised to 1, right? So what is the value of x here? The value of x is 1. So let's write first the formula. What is the formula? 1 plus x by 1 factorial. It is easy to remember, right? This formula, because it is 1 plus x raised to 1 by 1 factorial plus x raised to 2 by 2 factorial plus x raised to 3 by 3 factorial plus x raised to 4 by 4 factorial, x raised to 5 by 5 factorial plus x raised to 6 by 6 factorial, and so on. For the time being, I am only using up to 6 terms, up to 7 terms here. But if you take more number of terms, your value would be more accurate or more closer to the actual value. Okay, so by using calculator, the value is already known. What it is? 2.718281828, right? So let's find using power series, and what would be the value of e raised to 1. Okay, so we already know what is the value. 1. X value is what? 1 raised to 1. 1 raised to any term is what? 1 itself. So 1 by 1. Again, what it would be here? 1 square by 1 square by 2 factorial, that is 1 by 2. Again, what it would be here? 1 by 1 cube is 1 raised to 3 is 1 itself. So 3 factorial is what? 3 into 2 into 1. Into 1 I am not writing, it's just 3 into 2 I am writing. So the next term would be what? 1 raised to 4, that is 1 itself. Again 4 into 3 into 2, right? Next term would be what? 5 into 4 into 3 into 2 into 1, right? For the next term, what it would be again? 1 by 6 into 5 into 4 into 3 into 2 into 1. Okay, so we got the series. Now we have to add all these together. So what it is, 1 is 1. I'm writing it again. 1 by 1 is again 1. 1 by 2 is what? 0.5. Again 1 by 3 into 2 is 6. Again here it is what? 4 into 3, 12. 12 into 2, 24. Again what it is? 1 by 120. Again here what it is? 1 by 120 into 6, 720. So I would highly recommend you to have a scientific calculator or calculator to evaluate the values of power series. Then it would be very much helpful for you. Okay, now let's find what is 1 divided by 6. T 0.16. So I am writing it again. 1 plus 0.5 plus 1 divided by 6. 1 divided by 6. It is 0.166667. I'm taking up to 5 decimal places. Okay. So next term would be about 1 divided by 24. Again 1 divided by 24. That is 0.0416667. I'm again also approximating it to up to 5 decimal places. Okay. So sorry, 6 decimal places or 5 decimal places. Let's take up to 5 decimal places, so you will not have any confusions. Okay, now the next term would, what it is, 1 divided by 120. What would be the value? 0.00833. So this is the value for, I am just approximated again to 5 decimal places. And what is the value of 1 divided by 720? What is the value again? 1 divided by 720. 1 divided by 720. It is 0.00138. 0.00138. So now we have converted everything to the decimal places, and just now we have to add together. So let's add 1 plus 1 plus 0.5 plus 0.1667 plus 0.04167 plus 0.00833 plus 0.00138. It is 2.718805 I get when approximated to 5 decimal points. Yeah, so this is the value. You can see that up to 3 decimal places these values are correct. So what happens when you wanted to get the accurate value, you have to take lot of number of terms and then add it together. So I have taken only up to 7 terms in my problem. If you have taken more number of terms, you can see that your answer would be more accurate to the value you get in the calculator too. Okay. So also one more thing you can notice that, see, the first number of terms are larger numbers. Then once you go down, you can see that the value goes on decreasing. That's why I have approximated it up to 6 decimal place, 7 terms. You can see that when it is on the 7th term, the value goes to 0.001. Again, when I take the next term, it would be again a very small value. So neglecting that, that's why I have taken only up to 7 terms. Okay. So this is how you find the value of exponential functions using power series. And now let's find how to find again another problem using power series. Okay, so let's discuss. The first problem is already done, that is e raised to 1 and e raised to 0.5. Just to make sure, I'm just gonna find first the value of e raised to 0.05 using scientific calculator. What is the value? 1.05127 up to 5 decimal places. So this is the value using calculator up to 5 decimal places. Okay, so now let's find using the power series again. So what is the equation? E raised to 0.5, right? E raised to 0.05. Okay, now using this equation, only I am taking only here 4 terms because it is 0.05. It will just make your problems more complex when you take raised to 6 and so on. So I am taking only up to 1, 2, 3, 4, 5 terms. Only up to 5 terms I am going to take. So what will happen? So again 1, plus x value is what? 0.05 by 1. Okay, again here what it is? 0.05 the whole square by 2. That is 2 factorial. 2 factorial is what? 2 into 1. That is why I have written here 2. Again the next term would be 0.5 the whole cube by 3 into 2. What is 3 into 2? 3 factorial 3 into 2. That is 6. Again the last and final term I'm going to take is 0.05 whole raised to 4 by 4 into 3 into 2. That is 20. 4 into 3, 12. 12 into 2, 24. Okay, now let's add all these together and find whether we get an approximated value of these value. Okay, so 1 plus 0.05. Again here 0.05 whole raised to 2. That is 2.5 into 10 raised to 3 divided by 2. It is 1.25 into 10 raised to minus 3. Again the next term, what it would be? 0.05 whole raised to 3 divided by 6. What it is? 0.0000208. Again the next term, 0.05 whole raised to 4. What it is? Again divided by 24. Again what is the answer for that? 0. Oh, it's very like lot of zeros. 0.00. How many zeros are there? 3, 6 zeros. 4, 5, 6, 2, 6 and so on. Okay, I just need to check again the value of 0.05 whole raised to 2 divided by 2. That is 1.25 into 10 raised to minus 3. Okay, now let's add all these values together. Plus 1 plus 0.05. I made a mistake. 0.1 plus 0.05 plus 1.25 into 10 raised to minus 3 plus 0.000 zeros, right? So 4 zeros, 208 plus 0.6 zeros, right? 4, 5, 6, 2, 6. It's the value what I get, 0.1.05127. This is the value which I got. 1.05127. Yeah, almost the similar value which I got using the scientific notation calculator. And this is how you find the value of exponential functions using power series. I hope it's clear. So if you have any doubts on this lecture, please contact me under my email ID jojoslearningclub@gmail.com, or also you can comment under my video. I'll be always there to help you out. And a quick reminder, if you wanted to learn about any other lectures, please have a look on my playlist. I have other couple of videos where I've discussed on a lot of topics. You can just have a look on it. Okay, so that's all for today's video, and I'll be coming with further work problems on exponential functions on my next video. Let's see you over there. Bye bye. Take care.